So, as Bridget mentioned, I also have the honor of being the last speaker before lunch. I take this responsibility very seriously. So I will not only keep you awake and energized, but I will shut the hell up so you can get out of here on time. Cool, let's hit it. Let's hit it. Let's hit it. Here we are. Hi, y'all. My name is Nivia. I've been in tech for a very long time, have held many roles. I find that curiosity is the one consistent skill that has gotten me through tech and somewhat successful. I currently ply my trade as head of an engineering group at Spotify. Please buy our stuff. And I'm here to talk to y'all about something that's very important to me, not because I'm a data scientist or an ML engineer, but because, like many of you, I am a human. And as Bridget mentioned, it's very important to me that we utilize the agency that we have as technologists. And one area that I see as at risk to doing that is machine learning and automation. So that's what I want to talk to you all about. So specifically, we'll discuss the differences between what AI means, what artificial intelligence, machine learning, what are the possible harms they might have caused, though I think Jessica did a wonderful job of teeing that up, and the way to mitigate some of those harms. Cool. So let's get past some of the word salad just so that we have common language. So many people think that the relationship between AI, ML, and deep learning is sort of a nesting doll model. And that's not really the case. It's more like overlapping entities, whereby artificial intelligence really means human intelligence that are exhibited by machines. So we would think of something like TARS, which is from my favorite movie, Interstellar. But really, that's not where we are. Where we actually are today are clumsy but helpful, trying to be helpful robots that don't even get, putting things on shelves right. So, if we're worried about the machines taking over, yeah, we have a little bit of time to figure that out. So, machine learning is different. Machine learning is basically algorithms that learn using data. And the more data you provide, the more input you provide, the better. And sometimes, by providing data and trusting that the algorithms make the right associations, we get interesting examples like ordering diapers and also getting recommendations for Call of Duty 4. No judgment. So one thing about machine learning is that it's not a single thing, it's a spectrum. And it ranges from unsupervised learning to supervised learning at the ends of the spectrum, and then reinforcement learning somewhere in the middle. Unsupervised learning just means that there's more hands-on teaching of the model. So you provide not only inputs, but you also provide correct examples, and then you teach the model what are the correct and incorrect inputs, and then the outputs are things like labels and clear associations. On the other side, where unsupervised learning, it's more like you provide inputs still, but you have less control of the associations that they make, and the outcomes therefore are more complex, but also less predictable. And then reinforcement learning is something somewhere along the middle of that spectrum, as I mentioned before. So lastly, deep learning is sort of like a concentration of machine learning where it's cascading layers of processing where each input is used in the next layer to process to make the processing. So the best example is the convolutional neural network that a lot of self-driving technology uses. Some of them use over 250,000 inputs just to then tell the car to steer left or whatever else it will tell the car to do. And oftentimes people misassociate the words, so I want to clarify that what I'll focus on today, and most of what we interact with nowadays, is machine learning, and sometimes, in rare cases, deep learning, as I mentioned with the car example. But here's a dirty, maybe not so secret, is really, we're like, yeah, it works, great. I have no idea why it works. And that's because, again, there's a ton of complexity associated with machine learning and deep learning. And again, that information, especially when we move to the spectrum of unsupervised learning, we lose a lot of, again, the transparency that makes us understand how the machine, the model, ultimately arrives at its decision. And so, again, Jessica touched on this, but again, losing transparency and trusting the machine, the risk becomes we have no idea. It's harder to predict what is ultimately going to happen and whether or not the data is what we intended to, or the outcomes are what we intended from the machine, from the model. So why that's important is there's this concept by James Mickens, I hope I'm doing his name justice, but he talks about a concept of technological manifest destiny, which is the idea that we assume these three paradigms. We assume that technology is value neutral, and therefore more technology means more good outcomes. As exampled by Twitter and 8chan, hopefully y'all know that ain't true. We also think that, well, if all technology is good, let's get it out there as fast as possible. Who cares about understanding it? Let's just get it out there and see what it does. And then we're like, history, what's that? We don't actually recall and remember histories of where we had massive failures as a result of technologies that we've gotten too fast without understanding the impact. So with these paradigms, we're like, oh, we don't understand machine learning. That's great. Let's get it out there and see what happens. And here's what happens. So what happens ultimately is this concept called algorithmic bias. And there's a fancy internet definition, but basically it's when machines and models sort of adopt the decision errors that they learn from the data provided to them. And these have effects. These have real-world effects. Some of them are funny because they're just harmless error. Maybe autocorrect or autocomplete is a hilarious error that we might find, but then there might be bigger injustices like damaging one's brand, Google, injustice that could happen, or even physical harm, as we'll see in cases of driverless cars and possible military usage of ML. So I meant to have a trigger warning. So I am going to share with you some examples today that are triggering, they are disturbing, and I share them because I want to jolt us out of thinking that, oh, these are just models. We'll just TensorFlow it up and we'll sprinkle some machine learning on it and nothing will happen. And I want to show you examples of that not being true and the effects they have of it. So forgive me in advance. So I'll give you the first example that completely applies to me, because look at my hair, right? This happened about a year ago, I believe, where when one Googled professional or unprofessional hairstyles, the results were very different. And I wonder if y'all could spot the trend here on the professional versus unprofessional. Yeah, and this is again a result of this is a result of machine learning, because Google is a heavy user of models and algorithms in predicting and returning search results. And of course, the data collection and some other factors can get it very wrong. Here's another example. This is on a camera, and this is deeply offensive. I saw somebody just wince, and you're freaking right. I mean, that's awful. And again, this is another result of trusting our automation to get it right 100% of the time, and not understanding our actual users, and maybe not having the appropriate amount of representation to be able to catch these types of errors. Back to Jessica's earlier point, humans matter, y'all. And this one is especially disturbing. So this was a proprietary model developed for the Department of Justice that's been used pretty regularly in determining what to set bail at. And it turned out that model, even when compensating for factors like risk of reoffending and level of severity of the crime, on average, or repeatedly, they rated people of African American or people of color, a higher risk factor. And again, you can almost walk back to the data collection to see where the errors were made and how the model learned the wrong thing. And without having guardrails and humans there to interpret the data and to assess the actual validity of the outcomes, we see these kind of results that can literally result in an injustice for a particular group. And I have one more. This one's just funny, but the topic is very serious, and it's about deepfakes. Raise your hand if you've heard of deepfakes. Everyone has, so I'll just play the video.
Show me how.
The sound doesn't really matter that much, so it's okay if you can't hear it. But yeah, like, isn't it cool that Tom Cruise visited somebody's office? No, actually, Tom Cruise didn't. This is a deep fake. And the idea here is that deep fakes allow us to use machine learning and deep learning software to be able to overlay and faces of anyone that we want to on someone else. We can change their language. We can change the words they've said. And as we're already having a problem with information and trust and transparency in our systems, especially our political systems. Deepfakes has the risk of completely derailing our ability to discern accurate information, which will have downstream effects and impact on our political system and ultimately our lives. So you might be thinking, well, this is horrible, the people are horrible. And I would say, no, that's not true. Don't attribute to malice. This is not about malice. This is not about harmful intent. This is much more about lack of awareness and maybe a little bit of the manifestation of that technological manifest destiny that I talked about before. And so our jobs here isn't to say, well, just ban AI, just ban ML, because that's unrealistic as well. What we have to do is become more aware and also not lose the importance of having humans participate in these systems. So let's talk about, okay, well, what does that actually mean practically? In other words, how do we bust them ghosts? I actually just wanted to use this picture because I think it's so freaking cool. I don't care if I was talking about, I don't know, any other topic, I would have still used this and found a way to weave it in. Anyway, so first thing we have to do is clearly define the problem. I'm going to show you an example that's, again, triggering, and it's going to be an example of when you don't define the problem or you keep the problem scope too broad, and here's what the effects might be. How many of y'all remember Tay tweets? Good old Tay tweets. Did y'all know that it took Tay less than 24 hours to go from like innocent humanity-loving bot into like a complete Twitter asshole? Like, we turned Twitter Tay into like the worst thing possible in under 24 hours. I'm proud of us. Good job. And that happened primarily because we didn't understand the scope, or we didn't properly scope. So we took an original problem of how do we increase social connections, and how do we ensure that, or at least encourage others to participate in conversations by having some kind of innocuous Twitter bot that helps you generate conversation. And we're like, oh, this is a good idea. Now throw it to Twitter and see what happens. And this is what happens. So the ways to mitigate that are, first and foremost, consider whether or not your solution really needs to be an algorithm. Rules-based heuristics are simple, predictable, transparent, and oftentimes, I would say 80% of the time, more than capable of addressing your needs. Just because a technology exists doesn't mean we have to use it. When we are going to use it, though, try to define the objective and problem as narrowly and clearly as possible. Y'all are probably familiar with user stories. I would say put that concept and that thinking into high gear when you're applying machine learning by being super specific on the scope. Remember, these models are trained to learn through inputs. And sometimes if we derail or provide irrelevant inputs into these models, they'll learn the wrong things and it'll manifest in very strange and unpredictable ways. That's why we should also be very clear about the success criteria, what's acceptable, what's not acceptable. Maybe someone should have programmed Tay not to be racist, just thinking. And keep very clear scope and watch out for scope creep through your training data as you validate your model and put it out in the wild. So speaking of data, that's another aspect that's critical for machine learning. So just real quick, basically, there's usually multiple sets, when you're training a model after you actually design the model, there's multiple sets of training data that you use, not only to exercise it, but to also test and validate that it's accurate. And you have to keep those pieces of data very partitioned from each other so that they don't sort of corrupt one another. So here's another example of where the data really corrupted the experience in the model and the output was averse. In the United States, there was a facial recognition software that was being tested that would have eventually been used by a lot of major companies, including IBM, and it turns out that it easily identifies white men, but not black women. I can get that. And again, what happened here is they had a ton of data that, a ton of examples of white males and not enough examples of black women. Just to give you a counterexample of why this is not necessarily intentional, in Australia and New Zealand, the opposite happened. It was much harder to identify, I'm sorry, not Australia and New Zealand, it was in Asia, and I believe it was actually Japan. It was much harder to identify white men than it was to identify a different ethnicity group, again, for the same reason. There was an overpopulation of one set of data versus the other, so the model just got better at identifying the data that it was trained on the best. So ways to mitigate that, again, be super explicit about your data collection strategy. Understand what kind of data is necessary. Understand whether or not that data is varied enough to train and test against. And conduct an exploratory data analysis, which just means try to find and visualize ways of how the data is associated with one another. And there's many tools and techniques to do that, but the result is the same, which is sometimes when you lay out your data sets and you compare and contrast them in visual ways, you can see patterns that emerge that you might not have otherwise seen by just having sort of like a list of data sources. Whenever possible, use open source data sets into your models because, again, it just injects diversity in a way that your own data sets might not be able to. And then, of course, use crowdsourcing to fill gaps. This is assuming that you're all going to walk out of here at lunchtime, develop your own machine learning model, which I totally know you will. Next thing, representation matters. And Twitter's a freaking firestorm, but oftentimes I hear arguments about is it really that important for, for there to be actual diversity and representation in tech, because at the end of the day, what we really care about is building the best product and so on and so on and so forth. All that's garbage. And here's another reason why. First of all, it's important to know that machine learning engineer is one of the fastest growing types of engineering in technology today, but remember, over 60% of technologists and possibly the people who will assume these machine engineering roles are white males. And so what happens is we'll have very small representation of women, which again sort of misrepresents our data set, and of course of people of color, which is why we saw some of these things before. And the outcomes, again, are real, right? So here, Jarrett Hill posted that there was a machine, an airport body scanner that, went nuts because of, African American hair. And again, this is the critical reason why I say representation matter. It's not a philosophical conversation, y'all. It's about having the people in the room who look like the people who will use your stuff, because they will call things out that there's no way a program or an algorithm will find. If there was somebody with my hair in that scanner, we would have been like, hold up, this don't work. Right? We would have been able to identify that in 0.3 seconds, no tech needed. So another factor in machine learning models is making sure that, again, you institute guardrails and checklists. And what I mean by that are things like scoring your algorithms for bias explicitly, or having explicit conversations through ethics and working groups to ensure that, again, you're having these types of conversations actively and identifying bias from humans. Another really important one is conducting post-market surveillance, which is an idea that borrowed from pharmaceutical development, pharmaceutical product development, whereby even after the either device or medication is out there, they conduct continuous analysis and surveillance to ensure that, again, it's working as the sample group predicted and as expected. So here's some examples. I won't harp on them, but the idea here is that there are ready-made tools that we can use in order to do these types of ethical scans, and so use them. Find out what they are, talk to me afterwards, use them. And lastly, you have agency. Like, all of us here are technologists, and all of us here are humans for the most part. And so what we have to do, I know there's some robots hiding in the crowd here. What we have to do is we have to be super mindful about the things we contribute to. We have the power to say, yo, this is going to cause harm. Can we back up and talk about this? And some of us might even have the agency to say, I'm not signing off on this going to production because I don't feel that we've had these conversations about what the impact will be. And it will have, it won't go unnoticed. Recently, last year, Amazon workers demanded that Jeff Bezos cancel the face recognition contracts with law enforcement. And that got 126,000 flames, which is important in social media. But the point is, it generated conversation. And same thing, a group of scientists signed on to a manifesto asking that weapons do not use AI technology because it'll malfunction in awful ways and innocent people will be killed. Sadly, they were ignored. But the point is, they were using their agency just like we all can use ours as technologists. So, in summary, ghosts aren't real. Sorry, whatever TV shows exist on TLC. Algorithmic bias is, though. And it's up to us to mitigate and eliminate those harmful effects, because technology is neither good, it's neither bad, but it's also not neutral. All right, well, with that, my husband and cat, Andre and Lyra, thank you for your time today. And we have 6 minutes left for y'all to go get lunch. I finished on time. I aced this test. Yes!